Let's go ahead and look at some problems out of section 4.5. This is somewhat similar to what we did in 4.1, except now instead of polynomial functions, we're going to try and graph rational functions, which means now these are like functions that look like a fraction, that have a fraction in it. For instance, the first one we're going to do is pretty straightforward. It's going to be f of x equals 3 over x minus 4. Now once again, this is still similar to what we did a while ago when we were looking at inequalities. We actually did problems like this. So once again, we're going to still do the whole principle of sign charts. Now the new thing that we introduced in this section is what I did asymptotes. So we went over in class how to determine the horizontal and vertical asymptotes. So that's something that we now, of course, have to put on our graphs when we chart them. So let's just start out with this first one. There's nothing to factor. And let's go ahead and see what we have here. Let's first look for intercepts, x and y-intercepts. If I rewrite this as y equals 3 over x minus 4, to look at my x-intercept, I set y equal to 0. When you set y equal to 0, x is going to be 0. Just let me show you that. If I were to solve this equation, actually, I think I misspoke. You actually cannot solve this equation for x, because if you multiply both sides by x minus 4, you just get 0 equals 3. So actually, that's a little tricky. There is no x-intercept. Even I can get confused sometimes. Now for the y-intercept, that's where you set x equal to 0. And we do have a y-intercept of minus 3/4, so when we do our graph, we're going to have a y-intercept of 0, minus 3/4. Now let's go ahead and find the zeros and, well, let's do this next. Let's go ahead and find our asymptotes. Let's first find our vertical asymptotes. Remember, vertical asymptotes, you look at the denominator and decide what values of x would cause the denominator to be 0. So a vertical asymptote will occur when x is 4. So eventually when we create our graph, we're going to draw in a dashed vertical line through x equals 4. That's a vertical asymptote. Now a horizontal asymptote, you remember, is where we simply look at the leading terms of the numerator and the denominator. So 3 over x minus 4, I basically ignore the 4. So I say this is basically 3 over x. And when x gets really large, I can say this thing basically approaches 0. So my horizontal asymptote is going to be y equals 0. So I'm going to draw in a dashed line at y equals 0. And then I want to do a sign chart. Now the sign chart, my boundary points would normally be my zeros of x. Of course, there are no zeros of x. And my vertical asymptotes. So all I have is a vertical asymptote. So if I were to sort of start my graph and then do my sign chart, all I have is I have a vertical asymptote at 4. And then I have a horizontal asymptote at y equals 0. Let's draw that in for now, even though it doesn't impact my sign chart. And just for fun, let's go ahead and draw in our y-intercept, 0 minus 3/4. But the key is now, let's do our sign chart. So the only thing I need for the sign chart, I need to know the regions. So this vertical asymptote breaks it up into 2 regions. So only 2 regions for this graph. So it's going to be a pretty simple sign chart. Region, test point. I only have actually one factor, x minus 4. I guess I could put the 3 in here, although of course it's always going to be positive, but it's okay, I'll put it in there. Regions 1 and 2. I'll choose region 1, the test point is 0, and region 2, test point of 5. So for region 1, positive, negative, looks like region 1's negative. And then positive, positive. So I have a negative and a positive. So what's going on now? Sometimes this is a little bit more of an art than a science. The asymptotes, of course, are going to help define what this graph looks like, because this horizontal asymptote says as my value of x gets more and more negative, it's going to approach this line. So somehow it's going to look like this. And actually I should be careful because I know my line has to go through this point here. So I should make it more like this. And now, as I move across the y-axis, I have this other asymptote, this vertical asymptote. So hopefully it sort of makes sense that it must start to turn and then go like this. So this graph is sort of bordered by these 2 asymptotes. And now in region 2, since region 2 is always positive, likewise I have these 2 asymptotes. So hopefully you can sort of see that it would look something like this, where once again the asymptotes sort of define your graph. All right, so this is a little interesting. Like I said, you have to get a feel for these somehow. They can be a little tricky at first. Let's do a couple more examples. How about f of x equals 2x minus 4 over x plus 3. So let's go ahead and start with my, and I can call this y if I want. So let's start with my x-intercept. So if I set y equal to 0, I'd have 0 equals 2x minus 4 over x plus 3. If I multiply both sides by x plus 3, I have 0 equals 2x minus 4. If I solve this thing for x, I actually get x equals to 2. So I do have an x-intercept of 2, 0. Now if I try and figure out my y-intercept, that's when I set x equal to 0. 2 times 0 minus 4 over 0 plus 3 looks like I have a y-intercept of 0, negative 4/3. All right, now let's do our asymptotes. How about let's do our vertical asymptotes? Those are usually the easiest. Once again, vertical asymptotes. What value of x would cause the denominator to be 0? In this case, when x is negative 3. So when I get ready to draw my graph, I'm going to go ahead and draw an asymptote or a dashed vertical line through x minus 3. Now my horizontal asymptote, once again, in the top and the bottom, I throw out everything but the leading term. So I sort of eliminate the minus 4 and the 3, which means I end up with 2x over x, and the x's cancel out. So basically, I'm going to end up with a horizontal asymptote of y equals 2. So let's take all this information and let's go ahead and start to fill it into my graph. And then I'm going to go create a sign chart, and then we can try and actually do the graphing. So, I've got some intercepts and I've got some asymptotes. Let's go ahead, try and create a decent looking axes. All right, intercept, x-intercept, 2, 0. So I know at that point my graph's going to go through that intercept. Y-intercept, 0, negative 4/3, which is about maybe right about here. I have a vertical asymptote at x equal to minus 3. And then a horizontal asymptote at y equals 2. Now, to create my sign chart, my boundary points are my vertical asymptotes and my x-intercepts. Let me just write that. So my boundary points, in this case, are going to be, I have a vertical asymptote at minus 3, and then I have a x-intercept at 2. So in a sense, if I can somehow, I really don't want to draw a dashed line through my x-intercept because it's going to mess up my asymptotes. Really, I'd have one region here, and this is my second region, which goes from here to here, and then from here to here would be my third region. In other words, I don't want to draw a dashed line like I used to through this x-intercept, because then it's going to look like an asymptote. It's not an asymptote, but it is a 0 or an x-intercept. So I've really got 3 regions. So let's go ahead and now do our sign chart. So my factors are 2x minus 4, x plus 3, and then overall. I've got 3 regions. For region 1, I'll choose a test point of minus 4. For region 2, I'll just choose 0. And for region 3, I'll choose 3. So for region 1, it's going to be negative, negative, overall is positive. So region 1 is going to be positive. Region 2, when I have 0, it's going to be negative, positive, so region 2 is negative. The region 3, positive, positive, positive again. So let's figure out how this would look. Now this is where it gets a little interesting, and if you ever need to actually just plot some points. If you're not sure, you can always do that. So I know in region 1, this thing has to be positive, and I've got two asymptotes here. Hopefully you see that. If I tried to put my graph in this bottom part, it wouldn't work because all of a sudden it would have to cross the x-axis, and then all of a sudden my y becomes an egg, which it can't be. So hopefully it becomes pretty clear to you that it must be something like this for region 1. Now for regions 2 and 3, I've got these 2 points in this, so I can almost I know those points are connected, and then when I look, when I see region 2 is always negative, and I got this asymptote here, hopefully it makes sense. When you look at it, it would do that. And now when it goes positive, and I've got this asymptote up here, it's going to look like that. Once again, this is a little tricky sometimes. It just takes some experience, but doing enough of these, you begin to sort of see what they're going to look like. All right, one more example, even a little bit more involved. How about f of x equals x minus 2 over x squared minus x minus 6. All right. Of course, call this y. This I need to factor. If I factor the denominator, I believe it should be minus 3, x minus 3, x plus 2. So let's do our intercepts. For x-intercept, set y equal to 0. Hopefully you see if I multiply both sides by x minus 3 and x plus 2, I'll end up with 0 equals x minus 2. So it looks like I have an x-intercept of 2, 0. For the y-intercept, you set x is equal to 0. I'm going to use my original equation. It's a little bit easier when I set all the x's to 0. End up with negative 2 over negative 6. It looks like I have an x-intercept of 1/3. I mean a y-intercept of 1/3. So therefore I'm going to have the point 0, 1/3. Now let's do our asymptotes. How about the vertical asymptotes? Once again, I look at my denominator and see what values of x would cause the denominator to be 0. And I actually have two asymptotes, x equals 3 and x equals negative 2. And then the horizontal asymptotes, I take my original function. Let's take the unfactored one, because it's easier that way. And I eliminate everything but the leading term. So the minus 2 goes away, the minus x and the minus 6. So the function is approximately going to equal x over x squared, which reduces down to 1 over x. And as x goes to infinity, as it gets really large, it approaches 0. Or even as x approaches negative infinity, it goes to 0. So I have a horizontal asymptote, y equals 0. So let's start my graph, and then I'll do my sign chart, and then we'll see if we can figure out what it looks like. So I know you can't see the whole page, but let me go ahead and I'll move this page up and down as we need to. So it looks like all right, so look up here, I have an x-intercept of 2, 0. there's an x-intercept. I have a y-intercept of 0, 1/3. I have two vertical asymptotes, x equals 3, x equals -2. And then a horizontal asymptote of x equals 0. All right, now let's do our sign chart. So once again, my boundary points are going to be my vertical asymptotes and my x-intercept. So I have a vertical asymptote at -2, a vertical asymptote at 3, and a x-intercept at 2. So in a sense, I'm going to have, here's a region, the third region, is between 2 and 3, and then the fourth region is anything greater than x equals 3. So I have 4 regions. So I have, when I look at my factors, x minus 2, and then x minus 3, and then x plus 2, and then overall. So region 1, let's choose 3. Region 2, we'll go and choose 0. Region 3 has to be between 2 and 3. So let's just say 2.5, or you can think of that as 5 halves. And region 4, we'll just choose 4. Region 1, wow, should be -3, right? Hope I said -3. All right, so region 1, negative, negative, negative. Overall, it's negative. Region 2 is negative, negative, positive. So overall, it's positive. Region 3, positive, negative, positive. So region 3 is negative. This little region in here. And region 4, positive, positive, positive. Region 4 is positive. So now, once again, now this is where it becomes a little more of an art, because you think about the asymptotes and the signs. So region 1, if it's going to be negative, and I have a horizontal asymptote at y equals 0 and this vertical asymptote, hopefully by now you sort of see it's going to probably be one of these, right? And actually, if I go to region 4, that's also pretty straightforward. So I have these asymptotes again. Now regions 2 and 3 are a little trickier. Region 3, it's got to be negative. So somehow my graph has to be down here someplace. And then region 2, it's positive, and I've got these two intercepts, so these points must be connected. Now, this is a little tricky because you notice I'm actually going to, inside I'm going to cross my asymptote, my horizontal asymptote. Horizontal asymptotes are really for when the values of x get very large. When the values of x are small, when you're around the origin, you can actually cross or touch a horizontal asymptote. The asymptotes are really tell you what happened when the values of x get really large. So when x gets really large, here's an asymptote. When x gets to be a large negative number, here's an asymptote. But in here where all the action is, you can actually cross your x asymptote. So I believe what this one's going to be, it's going to come like this. It's actually going to then cross and then look sort of like this. All right. So that's how these graphs work. It's getting a little trickier, a little more involved. We have the idea of asymptotes, but as you do more and more of these, hopefully you'll get the hang of it.